Okay, so a little bit more on binomial expansion. Here, we're asked to find the fourth term in the expansion of x plus 2y to the 10th power. Now, what we want to be careful about is you can start off with expanding using the binomial theorem. I find that a good way to go if I don't have a technique to start with. But keep in mind, you don't have to expand it all the way out to the degree, which is 10. All you have to do is expand it out to the fourth term and you'd be able to figure it out. So let's go that way and then see if we can come up with any patterns to make maybe a shortcut for ourselves. So again, starting off, keeping in mind first term versus second term, our first term is a nice single x. Our second term of the binomial is a 2y. So slightly more complicated than just a y, but we can definitely do this. The degree, original power of the binomial, is equal to 10. So if we're going to use the binomial expansion, remember, if we're starting off with 10, we could start off with x plus 2y to the 10th power. Term number 1 would be 10, choose 1. And if we do 10, choose 1, we can do this for ourselves. Or should I say 10, choose 0? That might be a little nicer to go with. I think I'll go that way. 10, choose 0. This is kind of keeping in mind the value of our particular y exponent. So again, if we're looking at this, the x value will be taken to the 10th power, but the y term, 2y, will be taken to the 0 power. So we kind of recognize that some pattern I'm looking at is that these match up a bit. And again, we're always adding up to the degree. Okay, so that's term number 1, first term. So we don't even bother finding the value because why should we if we're only asked to find the fourth term? Let's look at the second term. 10, choose 1. That's going to leave us with x. Now we're counting down to the 9th. And now we have 2y to the first power. Again, just kind of keeping track. 9 plus 1 gives us 10. We do have our second term. And we want to take it out to the fourth term. So we have 10, choose 2. This will leave us with x to the 8th and 2y squared. As we're counting down with the x's, we're counting up with the y's. This will leave us with our third term. And now our fourth term, this is the one we're really concerned about. This is going to be 10, choose 3. The x power will be taken to, we're counting downwards, x to the 7th. And that will leave us with also 2y to the 3rd. So this, my friends, is our fourth term. This is the one we care about. We just have to take our time and compute it. So however you would like to do this, if you're interested in expanding out using Pascal's triangle, feel free to. But that kind of takes a little bit of time, mainly because if your degree is 10, you're going to have about 11 rows of Pascal. This might be a case where we pull up our TI or our combination formula. That might be even faster. So let's play around. 10, choose 3. Let's just find out what that is. So let's kind of take our time here. 10, choose 3. Now remember, a little recall for ourselves. We'll do this in purple. If we have n, choose r. Our formula for n, choose r, we have n factorial on top, r factorial in the denominator times n minus r factorial. So if we want to calculate 10, choose 3, that's 10 factorial over 3 factorial times 10 minus 3 factorial. Simplify it a little further. 10 factorial over 3 factorial times 7 factorial. And then we could use the idea of factorials to maybe simplify our math a little bit. I see 7 factorial in the denominator, so I can just knock off a few beginning factors of my 10 factorial. So 10 times 9 times 8, and then finally take the 7 factorial. So I have 3 factorial, 7 factorial, and then kind of notice, oh yeah, it's super cool. We can divide out our factorials. So now it's kind of a matter of just doing the math. There's a lot less to multiply. So what do we have? 10 times 9 times 8. I'll actually take my TI. 10 times 9 times 8. I guess I don't have to. I could do some reducing when I multiply 3 factorial, which is what, 3 times 2 times 1. I could have done this a little bit cleaner. But I have 720 over 6. And we'll see, sometimes we end up with a fraction, sometimes we end up with a nice whole number. So I'll just divide 720 divided by 6. Right, Leica? Yes, you thought I should have reduced first, I get it. So we have, finally, we have a 120 as our coefficient. So that's kind of how to do it by hand. I'll just replace this 10 choose 3 with a 120. And then now, my friends, we're looking at x to the 7th. We are looking, we don't even have to do that much. X to the 7th is just x to the 7th. It's really multiplying out 2y cubed. So 2y cubed, everything's positive. 2 times 2 times 2 gives me 8. I end up getting y cubed. And then now a little bit of simplification. What do we have? 120 multiplied by 8. Little TI help. 120 multiplied by 8, we will have 960. Then we have x to the 7th times y cubed. Yes, Leica, that's right. X to the 7th times y cubed. Notice that the powers on the x and the power on the y adds up to 10. So this, my friends, is the value of our 4th term. So it didn't take us that long to kind of figure out the patterns. I would like to point out, 1 second, please. I would like to point out that you do enough of these, you end up not having to expand out the terms. You know, and the 4th term's not so horrible, but what if it asks for the 9th term? Takes a little bit of time. So just kind of some patterns to keep in mind. There's a couple ways we can apply this. If we are recognizing that our degree is 10, so alternatively, our thoughts, so pattern recognition. And that's my key on a lot of these things. I don't like to memorize formulas because they get mixed up in my mind. If you understand that the degree is 10, that automatically gives you the upper number in the binomial coefficient. So we end up getting, just from this, we could automatically determine that we have 10 choose something. Now, if you're talking about the 4th term, the way things work out, if you're starting with zeros, if you can kind of look at my expansion with me in pink. We start off with 0 as our bottom number in the n choose r, and the power of y is 0. Then we notice for our 2nd term, we start off with 1. And the power of the y term, or the 2nd term, is 1. So then, moving forward, the bottom number is 2, the power is 2, but compare this to the term number you are on. If you look at the term number you're on, term number 1, you've got 0. Term number 2, you've got 1. Term number 3, you've got 2. Term number 4, the bottom number and the power of that second term in the binomial is 1 less than the term you're on. So that R part. So let's see the R. I'll kind of write this down. R is always equal to 1 less, and I'll kind of talk about this as term number subtract 1. So again, our term number is 4. That's the one we want to find. Subtract off 1, and we get R is 3. So now we end up having our coefficient just from this, 10 choose 3. So that, my friends, is probably the roughest part to figure out, because you kind of have to recognize, okay, if it's the first term, it's 1 less. But now what you can do is understand that you are looking at the power of the second term, which is always related to that R part, no matter where you go. So if you're trying to build up the factors, you can talk about the power of 2y. That's the second term in the binomial. And I'll separate this out because that's slightly different. The power of 2y always matches the R, which is in our case 3. So we're almost set. We do have our term. Let's put this all together. Our fourth term. Now we know that it's 10 choose 3. We will have x to some power. That's the first term. But the key is recognizing the power of the 2y. We know it matches, it always matches the R. And then we have an idea of what happens is when you want to figure out what term you're on, the power of the x must add up. If you add this to the power of the second term, it must add up to 10. So the power of the first term needs to be a 7. So you're kind of doing this in a way thinking backwards. And if you guys look at how we develop the fourth term, you will notice, I don't know, I can circle this and I'll draw a big arrow. See, this is how we're developing it. So if you're happy to recognize the patterns, like you do a lot of these, you start realizing, oh yeah, I have this down. I can take a shortcut and build my term based off of this pattern recognition. If that is not your cup of tea, I understand. When you first start off, expanding the first few terms helps you figure things out as well. But if you're also into memorizing formulas, they do have a formula for the nth term of a binomial, or we'll say Arth term, because we use nth term as degree. So one last formula, if this is something you are interested in, again, feel free to ignore it. If you already understand how to expand things, it's kind of what we stated in our pattern recognition, but it's stated in a nice mathematical way. So this is the Arth term formula. So again, what we were trying to get at is if you do, I think the key is memorizing or figuring out who R is. It's always 1 less than the term number that you're on. So if you understand what R is, you can kind of figure out everyone else based on what's given. So again, in our case, if our degree, let's see, our degree was 10, which in our case, usually it's n. We've got that down. And R is always 1 less or than the term, or R minus 1, we'll say. So this is always taken care of as, let's see if I can do this with the R. There we go. This part, our fourth term, is going to tell us that R minus 1, 4 minus 1 gives us our 3. So that's another way to talk about it. And once you know this bottom number, they match. So if we're building everyone one more time. Bear with me. I have 10 choose 3. R is 3. So they match again one more time. And then the idea between this formula right here, I'll try to highlight it in purple. N minus R minus 1, all they're trying to say is it's supposed to add up to the degree. So if we're looking at this first term, by the way, our first term or second term was 2y. Our first term is just an x. So you're saying x to what power? Well, they have to add up to 10. So 3 plus what gives us 10. In the formula, they end up using subtraction to kind of figure out that missing addend. So that's where we're getting the 7. So that's another way to do this. And you'll notice, yeah, it still matches up to our formula that we used over here. I'll draw another arrow. Feel free to utilize any way that you find comfortable with finding the particular term, and you should be fine. So I hope this helps. Even with a little pattern recognition, that might save you maybe a few minutes, but remember, we don't want to save minutes and then sacrifice our accuracy. So if you're interested and you just like expanding things out, I think sometimes that helps you at first. So we'll do another one in the next example. I'll see you then.